Okay, we talked a little bit about DNA. This is a DNA results using electrophoresis. If we have enough time in this class, we'll maybe do one. But like I said, if you're into DNA and that kind of stuff, most of that gets done through biotechnology, where we take a genetic fingerprint and analyze it. This has been available since the 1990s, but it's been so expensive that it hasn't been until just lately that it's been used more commonly. But it can come from any fluid, and it's like a genetic fingerprint. So you can see that these two people are the same or have the same genetic markers, and these right here have the same genetic markers. But this one doesn't have similar genetic markers to anyone. These long ones are markers. We know what lengths these parts of the genetic code are, so we put them in there as like ladders. A marker is sort of like a ladder, so I can say, oh, I know what this is, so this is just a little bit above it, so it's between this marker and this marker, so I know how long this DNA strand is. Okay? So let's go back to that. So here we have the victim. So we've got a female fraction right here, and then we've got a sensitivity control, nothing's there, and then they've got a male fraction, and then we've got the known suspect, and it matches with the male fraction. All right, so on the next page, you've got a few things here. I want you to take a look and look at the individual things. I'm not going to tell you anything. It's very simple to look at. And I want you to tell me if each alleged father could possibly be the father. Now remember, every child gets one allele from one parent and one allele from the other parent. So you've got this in your notes. I want you to look at it in your notes and tell me, is the alleged father a possibility? Yes or no? Yes or no? Yes or no? Yes or no? Okay, do you have your notes? And it's sort of like what we did with our fingerprinting. We're trying to match spots. Okay, and this is on the next page. There you go. So you should have these. I want you to tell me, like I said, could this alleged father actually be the father of this child? The mother and the father. And circle the one that tells you if it is or is not. Okay, let's come back together. What did you think about this first one right here? A, B, C, D. Do you think this alleged father could be the father of this child? Yes. Yes, what point tells you that? C. C tells you that. Okay, what about E, F, and G? Is that alleged father a possibility to be the father of that child? It's the E point there that you're looking at for that one. And it's yes. On the next one, this could be questioned because you're looking at the center of this and the center of this, and it's a little off. You see that? Because it's a little off, but there's also all this drag in here, that means I probably have a not pure sample. Something got messed up in there. So this one would need to be rerun because it could be, but I can't prove beyond a shadow of doubt that it is because it's not exactly the same. Okay, and I look at the next one here, and the same thing is here. This might be this one cleaned up a little bit, run a little bit, but the center versus the center, It's a little off. Okay, so I want to make sure I run that again, because possibly, maybe, but not definitively. Okay, so DNA is unique to an individual, whereas blood typing can only eliminate an individual as a suspect. Blood type is a class evidence, and this is something you need to remember. Blood type is a class evidence. DNA is an individual evidence. So when we talked about this in first term, it's coming back to haunt you. So class, I can narrow it down to a class of people that have a B positive blood type. But DNA is an individual. It brings it down right to that person. You probably heard it called on CSI shows. It's called DNA profiling or DNA typing. Okay. All right, now we get down to evidence handling. We've handled dry stuff so far. Now blood is wet. Okay, so it's crucial that blood stains at a crime scene are documented, collected, and tested and preserved and analyzed correctly. Failure to do so will weaken or destroy potential evidence. So, first thing always at a crime scene, after we've laid out our markers of where the evidence is, what's the next thing that we do? Always. Or should have done always. Photos. Okay, because photos don't disrupt the scene. The minute you start collecting evidence like he's doing up here, or she's doing up here, then you've started to disrupt the scene. So you want photos of the scene to start with. Everything as it was. So this would be an evidence photo of a blood spatter. Okay? And we would then make sure we identify which one it is. The thing that's wrong with this one is they have not got the evidence marker on it, so I don't know which one it is. It's just a photo. Okay? So we didn't have the evidence marker in the photo with the evidence. Then we have to try and pick the cleanest area to grab the stains from. Now that's not always possible. When we go into a scene like this, if we're going to be using DNA evidence, we have our hair covered, we have goggles on, we have masks on, we have gloves and clean suits on, we have booties on, all geared up. Because we don't want to have any of our DNA be contaminating the scene. So we need to make sure that this is a hard thing too. After every sample that we take, we change gloves. Because otherwise we would be cross-contaminating a scene. Another rookie mistake is trying to blow on a sample to make them dry faster. Well, what are you doing when you're blowing on a sample? You're putting your DNA on the sample. Okay, so you don't touch any of the blood samples with non-disposable items. So you want to make sure you're using clean tools that have been cleaned with 10% bleach and thoroughly dried, because otherwise it can contaminate. So if I pick up a sample like this, there's two ways that I can go about storing it, and only two ways. The first is to allow it to air dry, and then I can bag it and put it away. I cannot bag anything wet. Okay, it won't. So either I do it that way, or I put it into an instant freeze. So I put it into a freezer that's portable, that's plugged in, and it freezes it. And I only bring it out to analyze it. Okay, so those are the only two ways that I can pick up evidence and maintain it. All samples have to be separated. So even if it's drip, 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 and I take one sample here, it goes in a bag. Another drip, and that goes in another bag. Another drip goes in another bag. Cannot cross-contaminate. Okay? Garments need to be put in paper bags, not plastic, and they need to be allowed to air dry. Okay? If it's the multiple garments, one garment in each bag. And then, like I said, paper bags don't limit the air exposure, so we want to make sure that we have paper. We don't want to use tubes or paraffin or plastic baggies for blood evidence, or serology evidence, which could be saliva, any mucus, any semen, anything like that. Okay. So evidence handling, proper evidence handling packaging is crucial to protect against loss, contamination, deterioration, cross-transfer, suspect scene, item, victim, and biohazards. Because you don't know if the blood that's being left has HIV, has some biological hazard that you need to be careful with. Never package blood evidence while wet unless you put it into an instant freeze. Blood stain material should not be stored in airtight containers. Like I said, paper bags is where we use most of them, or wrapping paper if it's really big. You air dry the clothes and place them in individual separate bags. Char debris from a fire is sealed in airtight containers though. So if you have a fire and something is charred, then you do put it in an airtight container because you don't want to contaminate or lose any of the evidence that can be given off by char. Biological materials must be dried before packaging to prevent deterioration. We talked about that a little bit already. If they have wet, they usually bring it in a paper bag, and in the forensic area of the police department or in the lab, there's what they call a drying oven that just basically blows air one way through and sort of takes it off. It's not really gun or heat fan. It's just more of an area that helps so it doesn't cross-contaminate. We do use paper containers for biological evidence, and we seal tape across just like we do with the plastic, with the initial and date over the seal. So these are paper bags that are evidence things. Again, same thing that we've been doing, that what is in there, where did you find it, chain of custody is still there, case and item numbers, health hazards, if there's any health hazards, this is blood, whatever, storage condition, this is stored at room temperature because it's dry, or this needs to be frozen or refrigerated, and sample needs to be processed quickly, anything like that. I'm still trying to figure out how to get this without these paper bags with the evidence thing on without costing me an arm and a leg. So we'll see. We might just be making our own labels. Okay. Evidence storage, biological evidence should be stored in dry areas to prevent bacteria or mold or growth, or in the freezer. It's important. What evidence should be stored frozen? Some portions of the sample should be preserved from destructive testing. So what that means is if I'm going to go test something, like with the presumptive test or the conclusive test, I don't want to use all my sample to make that one test. I want to make sure that some of the sample is always reserved for later. Okay. All right, so you've got your assignment to work on for the rest of the time. Got about 10 minutes. The books are over here. As you finish, we take any low score quizzes, we submit any low quiz assignments, and remember quizzes will continue to count as test scores. We'll have a term final test with these questions on it, and that's we might have one, we might not on that. Next, crime scene reconstruction with blood stain pattern analysis. So we'll go with that. Okay, any questions? All right, work.